Welcome, friend. Tonight, you don't have to do anything complicated. You don't have to learn perfectly, or remember perfectly, or even listen perfectly. You can simply rest and let these words be like a slow, steady breeze passing through your mind. If you're in a place where it's safe to sleep, let your body settle in whatever position feels easiest. And if you're still awake at the end of a sentence, that's completely fine. We're not chasing sleep, we're inviting it. If you happen to be driving or doing something that needs your attention, just keep your eyes open and stay with the road. You can still enjoy the calm, just in a wakeful way. Now, take a gentle breath in, not too big, just comfortable, and let it out slowly, as if you're letting the day pour out of you. One more, in, easy and quiet, and out, unhurried, soft at the end. Good. There's no special technique required, just the simple rhythm of being here. Tonight, we're going to drift through the Milky Way galaxy, not in a hurry, not with any pressure. Just a slow nighttime journey, one that you can fall asleep during at any moment. Here's our little sleep agreement, our sleep contract, as gentle as a blanket. You are safe in this moment. You are allowed to rest. You do not need to hold on to every detail. If your mind wanders, that's normal. If you forget what I said, that's perfect. This is low effort. You can listen, or you can float. And if you notice thoughts popping up, lists, worries, replayed conversations, imagine setting them down beside you, like placing a book on a bedside table. You can pick them up tomorrow. For now, they can wait. In a moment, we'll begin with 100 calm facts about our galaxy. But first, let's gently widen our view. Picture the room you're in, quiet, dim, and still. Now imagine the building around you, the neighborhood, the city, or the countryside. Not in sharp detail, just the idea of it, like a soft watercolor. Then the shape of your region, your state, your country, all resting on the round, steady earth, and the earth turning slowly, like it always does, without asking anything from you. As you breathe, imagine we're rising, just a little, above the clouds. The planet becomes a calm blue and white sphere beneath us. We're not rocketing, we're not rushing. We're simply drifting upward, as if we're weightless in a quiet dream. And as we drift, it's okay if images come and go. You don't have to see anything clearly. This is just a gentle story for your nervous system, a soft place for your attention to rest. Now, out beyond Earth, the stars appear. First a few, then many. The darkness of space isn't empty. It's more like a deep ocean at night, vast, peaceful, and full of distance. Somewhere among those countless points of light is our sun, and the small familiar planets that circle it, including Earth, the place your body is resting. Right now, and that sun is not alone. It belongs to a much larger home, the Milky Way galaxy. Before we begin our first facts, a quiet little note, only if you feel like it. If you enjoy drifting off with astronomy like this, you can gently support the channel by liking this video or subscribing for more calm space journeys. No urgency, no pressure, just a soft invitation. Now let's begin in the most restful way possible, slowly, kindly, with a sense of wonder that never needs to become loud. We're going to explore the Milky Way as if we're gliding over a nighttime map, pausing at peaceful landmarks, letting curiosity be a candlelight glow, not a spotlight. So let your shoulders soften again. Let your jaw unclench. Let your hands rest heavily, as if gravity is kindly holding them down. And as we start, remember, you can fall asleep at any point. The Milky Way will still be there, quietly spinning, patiently waiting, whether you're listening or dreaming. Now that we've settled in, let's lay down a few gentle definitions, like placing soft stepping stones across a quiet stream. Nothing to memorize, just enough clarity so the rest of our journey feels smooth. First, the word galaxy. A galaxy is a vast, bound-together community of matter, mostly stars, but also gas, dust, and something mysterious called dark matter, which we'll meet later in a calm way. The key idea is gravity, the same gentle force that keeps you grounded in bed right now. Gravity is like a slow, patient hand. Over billions of years, it gathers things together. It encourages clouds of gas to collapse into stars. It holds star clusters and spiral arms in place. And on the largest scales, it holds whole galaxies together like lanterns hanging in a dark hall. When we say the Milky Way galaxy, we mean the specific galaxy we live in, the one that contains our sun and every star you've ever seen with your naked eyes. And here's the cozy, slightly mind-bending part. We're trying to understand it from the inside. It's a bit like trying to map an entire forest while you're standing among the trees. That's why we need careful measurements, clever instruments, and a little patience. To talk about distances this large, astronomers use a unit that sounds poetic: the light year. A light year is not a measure of time, it's a measure of distance. It means how far light travels in 1 year. Light is incredibly fast, so fast that it can circle Earth multiple times in a single second. And yet space is so large that even light, racing along at that incredible speed, needs years to cross the gaps between stars. So when someone says a star is 100 light years away, they're really saying, the light arriving at your eyes tonight left that star about 100 years ago. Not because it was delayed, just because the distance is that big. There's another distance unit astronomers like, especially for careful mapping, called a parsec. You don't need the math. The soothing version is this. A parsec is another way to measure large distances in space, and it's based on a simple geometry trick: how an object seems to shift against a background when you observe it from two different points in Earth's orbit. 1 parsec is a little more than 3 light years. That's it. You can let the word parsec float by like a cloud. The important part is that astronomers have reliable rulers, ways of measuring, so the Milky Way isn't just a guess. It's a carefully drawn map, refined again and again. Now let's talk about the name Milky Way, because it comes from a very human experience. On a truly dark night, away from city lights, you can sometimes see a pale band stretching across the sky. It can look like a faint river of milk spilled across black velvet. That glowing band is the combined light of enormous numbers of distant stars, so many and so tightly packed along our line of sight that your eyes can't separate them into individual points. They blend into a soft, luminous haze. And here's the reason it looks like a band. We are inside a galaxy shaped roughly like a flattened disk. Imagine standing inside a thin, wide pancake of stars. When you look along the pancake, edgewise, you see a lot more stars in that direction, layered one behind another. The light adds up. When you look up or down out of the disk, there are fewer stars in that direction, so the sky looks darker. So the Milky Way in the sky is not a separate object out there. It's home. It's the structure you're embedded within. And because we're inside it, some regions look brighter than others. Toward the center of the galaxy, the star density increases, and the Milky Way band often looks richer and more textured if you're in a place dark enough to see it. But there's also something that blocks our view: interstellar dust. Dust in space isn't like fluffy household dust. It's more like tiny grains, microscopic bits of carbon and silicates, drifting through the galaxy. This dust absorbs and scatters visible light, like fog. That's why some parts of the Milky Way look patchy or darkly veined. Those are dust lanes, quiet shadows in the starlight. And that's why astronomers don't rely on visible light alone. They also use infrared light, which can slip through dust more easily, and radio waves, which can reveal cold gas clouds, especially the hydrogen that fills much of interstellar space. Different kinds of light are like different senses. Visible light is like sight in daylight. Infrared is like seeing warmth. Radio is like hearing whispers of gas across vast distances. By combining them, we build a fuller picture, one that doesn't depend on a single, dusty viewpoint. So tonight, as we begin our 100 facts, you can keep a simple mental image: a calm, spinning galaxy, shaped like a disk, with spiral patterns. And we are tucked inside it, not at the center, but out in the quieter suburbs, traveling around the middle at a steady, unhurried pace. We'll move through this map gently, fact by fact, like counting slow footsteps on a nighttime walk. And if any word feels unfamiliar, you can let it pass. Your body already knows what to do. Your only job is to rest. Let's begin our first set of gentle facts, like counting slow stars drifting past. Fact 1. The Milky Way is a galaxy, a gravitationally bound system of stars, gas, dust, and dark matter, all moving together through space. Fact 2. The Milky Way is classified as a barred spiral galaxy. That means it has spiral arms, and near the center, a stretched out structure of stars called a bar, like a soft, luminous bridge across the middle. Fact 3. The Milky Way is big, so big that astronomers usually describe it in the language of light. A common estimate is that it's on the order of 100,000 light-years across in its main stellar disk. Not like a perfect circle, more like a vast, slightly uneven, living shape. Fact 4. Even though we talk about the Milky Way as one object, it has layers and regions, a bright central bulge, a wide disk where most stars are, and an extended halo that reaches farther out than the visible stars. When you feel ready, you can imagine it like a calm, glowing whirlpool, denser in the middle, thinner at the edges, and gently surrounded by a faint, spacious halo. Fact 5. From Earth, we can't step outside the Milky Way to take a simple photograph of it. So a lot of what we know comes from careful mapping, measuring distances to stars, tracing gas clouds, and using many kinds of light, visible, infrared, radio, and more. It's like trying to understand the shape of a house while you're inside it, walking its hallways, listening for echoes, and measuring the angles of the walls. Fact 6. The Milky Way looks different depending on the kind of light you use. In visible light, dust can hide whole regions. In infrared, more of the inner galaxy is revealed. In radio, we can trace cold gas, especially hydrogen, spread throughout the disk. So when you see different Milky Way images online, it isn't that one is wrong. They're simply different views, like hearing the same song on different instruments. Fact 7. The spiral arms are not rigid structures like solid tubes. They're more like patterns, regions where stars and gas are a bit more crowded, where star formation is often more active. Stars orbit the center, moving in and out of these patterns over time. So the arms are real, but they're also dynamic, more like traffic lanes than carved grooves. Fact 8. The Milky Way is not alone. It lives in a small neighborhood called the local group, alongside other galaxies, some large, some small, held together by gravity over immense distances. It's a comforting thought. Even galaxies have neighbors. Fact 9. When you look at the Milky Way band in the sky, you're looking through the disk of our galaxy. You're seeing the combined light of many stars at once, layered deep into the distance, like countless porch lights seen through a soft fog. Fact 10. The Milky Way is old, on the order of billions of years, and it has been changing the whole time. Stars are born, live their long lives, and return material to space. The galaxy slowly reshapes itself, gathers new material, and gently evolves, without hurry, without drama. Just time doing what time does. And that's our first 10 facts. Simple, steady, and spacious. If you'd like, take another slow breath in and let it out as we drift toward our next cluster of facts, closer to our own address inside this vast, quiet home. Now we'll drift a little closer to home, not to a street or a city, but to our quiet place inside the Milky Way. Think of this as writing a gentle return address on an envelope made of starlight. Fact 11. Our solar system is not near the center of the Milky Way. We live partway out in the disk, in what you could call the galaxy's calmer outer neighborhoods. Fact 12. Astronomers estimate that the Sun is about 25,000 to 26,000 light-years from the Milky Way's center. That number can be refined over time, but it gives a comforting sense of scale. We're far from the crowded middle, with plenty of space around us. Fact 13. The Milky Way has a kind of equator called the galactic plane, the central plane of the disk, where most of the stars, gas, and dust are concentrated. So when you see the Milky Way as a band in the sky, you're mostly looking along that plane, like looking along the horizon of a glowing, starry ocean. Fact 14. Our solar system sits in a region often called the Orion Arm, or the Orion Spur. Spur is a gentle word here. It means we're in a smaller, partial arm, more like a branching lane between larger spiral arms than a main highway. Fact 15. Nearby, on the inside track closer to the center, is a larger spiral feature often called the Sagittarius arm, and farther outward is another major feature called the Perseus arm. We're tucked between them, comfortably in between. Fact 16. The Sun and almost everything we can see in the night sky is orbiting the center of the Milky Way. Not like a tight circle, and not all at the same speed, but in a broad, steady motion guided by gravity. And you can picture this very softly, a slow carousel of stars, turning so gradually that it feels more like time itself than motion. Fact 17. Our orbit around the galaxy is fast in human terms, hundreds of kilometers each second, but it feels quiet because space is so vast and the journey is so smooth. Even now, as you rest, you're moving with Earth and with the solar system and with the Milky Way, all layered together in a calm, cosmic flow. Fact 18. One complete trip around the Milky Way's center, sometimes called a galactic year, takes the Sun roughly a couple 100 million years, often estimated around 225 to 250 million years. So the last time the Sun was in the same part of its orbit, Earth was a very different place. But you don't have to imagine that in detail. Just feel the softness of the timescale, how the galaxy teaches patience simply by existing. Fact 19. Because we live inside the disk, many of the brightest stars we see are our near neighbors within that same disk. Stars that share the galaxy's general rotation, like boats drifting in the same slow current. Fact 20. Astronomers use a sky map system called galactic coordinates, a way of describing directions in the sky based on the Milky Way's plane and center, rather than Earth's equator. It's like choosing to navigate by the shape of the galaxy itself, using our larger home as the reference. And that's facts 11 through 20, your gentle galactic address. If you'd like, let your mind rest on a simple image, a wide, starry disk, a soft spiral pattern, and our sun, quietly traveling along a long, calm path. Not special because it's central, but special because it's ours. In the next set of facts, we'll explore the Milky Way's shape more closely, its layers, its thickness, and the way it's not perfectly flat, but subtly, beautifully warped. Now we'll gently explore the Milky Way's overall shape, like tracing the outline of a familiar place in the dark with a soft fingertip. Fact 21. The Milky Way is shaped roughly like a flattened disk, wider than it is tall, because much of its material settled into a rotating plane over time. Fact 22. Astronomers often describe two main layers in that disk, the thin disk and the thick disk. These aren't hard boundaries. They're more like overlapping zones, two soft blankets laid over the same bed. Fact 23. The thin disk contains a lot of the Milky Way's gas and dust, and it's where much of the ongoing star formation happens. If you imagine the galaxy as a glowing record, the thin disk is the brightest, most active surface. Fact 24. The thick disk is puffier, more spread out above and below the galactic plane, and it tends to contain older stars on average. It's like a faint, older echo of the disk, surrounding the thinner, busier layer. Fact 25. Near the center, the Milky Way has a dense region often called the bulge. The bulge is crowded with stars, and it's part of why the Milky Way band can look brighter in the direction of the constellation Sagittarius, where our galaxy's center lies in the sky. And if you don't know Sagittarius, that's perfectly okay. Just think, toward the center, more stars gather. Fact 26. Beyond the disk and bulge is the halo, a vast, faint region surrounding the galaxy. The halo contains some stars and star clusters, but it's much emptier than the disk. It's more like a quiet, spacious atmosphere around the brighter, busier city of the disk. Fact 27. Some of the Milky Way's oldest star clusters, called globular clusters, orbit out in that halo. They're like ancient lanterns, traveling on wide paths around the galaxy, quietly keeping time. Fact 28. The Milky Way's disk isn't perfectly flat. It's slightly warped, as if the edges have been gently lifted and bent. Not sharply, not dramatically, just a subtle ripple in the structure. Astronomers think this warp may be influenced by the gravity of nearby satellite galaxies and the larger distribution of mass around the Milky Way. The details are still an active area of research, but the calm truth is, our galaxy is a living shape, not a rigid object. Fact 29. The spiral pattern we talk about, those graceful arms, is easiest to trace using gas and dust, because those materials tend to gather along the spiral features and form bright star-forming regions. So when astronomers map hydrogen gas in the Milky Way, they're also sketching the galaxy's grand design. Fact 30. Even though the Milky Way is enormous, it has a kind of coherence, a shared rotation, a shared gravitational home. Stars can have their own slightly different paths, drifting up and down, in and out, but overall, the galaxy holds together like a slow, steady whirl, a quiet choreography that has been unfolding for billions of years. If you feel yourself getting sleepy here, that's perfect. Let these shapes become simpler in your mind. A soft, wide disk, a faint, spacious halo, a gentle bulge at the center, and a subtle warp, like a slow wave frozen in starlight. In the next cluster, we'll drift inward, toward the crowded heart of the Milky Way, where we'll meet Sagittarius A, the supermassive black hole at the center, in the calmest way possible. Now we'll drift inward, toward the Milky Way's center, not with any intensity, just a slow glide, like floating toward the warm glow of a distant town seen from far out on a calm highway at night. And remember, you don't have to picture this perfectly. You can let the center be more of a feeling than an image. Fact 31. The center of the Milky Way lies in the direction of the constellation Sagittarius. So when people say toward the galactic center, they mean a particular direction in our sky, one that astronomers use as a reference point. Fact 32. The galactic center is difficult to see in visible light because of interstellar dust. That dust acts like a soft curtain, blocking and scattering starlight. So, to study the center, astronomers often use infrared and radio observations, which can pass through dust more easily. Fact 33. Near the Milky Way center is a region of intense star density called the central bulge, where stars are packed far more closely than in our quieter neighborhood. If our region is like a peaceful suburb, the inner bulge is like a bright downtown, crowded, layered, and full of motion. Fact 34. At the very center of the Milky Way is a supermassive black hole called Sagittarius A, often shortened to SGRAR, and we can speak about it in a calm way. A black hole is not a cosmic vacuum cleaner roaming around. It's simply a region where gravity is very strong, packed into a very small space. Fact 35. Sagittarius A has a mass of roughly 4 million suns. That number sounds huge, and it is, but space is even larger. And at this moment, Sagittarius A is relatively quiet compared with the actively feeding black holes in some other galaxies. Fact 36. We know Sagittarius A is there because we can observe stars orbiting something invisible at the center. Stars moving fast on tight paths, as if circling a hidden anchor. It's one of the most soothing kinds of evidence, patient observation over time. Night after night, year after year, astronomers watch the same stars trace their loops, and the math points to a massive, compact object. Fact 37. The distance from our solar system to the galactic center is about 26,000 light-years, give or take, depending on refinements in measurement. So when we talk about the center tonight, we're talking about something unimaginably far away, so far that it remains a distant landmark, not a nearby presence. Fact 38. The region around the center contains hot gas, dense clouds, and energetic processes, but it's also full of structure, streams of gas, clusters of stars, and magnetic fields shaping the motions of charged particles. You can imagine it like weather around a mountain range, not chaotic, just complex. Patterns within patterns. Fact 39. There are large clouds of molecules near the center, cold, dense regions that can serve as raw material for future stars. Even in a place that seems extreme, the galaxy still follows its slow, familiar cycle, gathering, compressing, forming, dispersing, and gathering again. Fact 40. When astronomers observe the center in radio and infrared light, They don't just see a single bright point. They see a whole environment, an ecosystem, where gravity, gas, dust, and starlight interact. And through it all, the galaxy keeps turning. If you like, take a quiet breath here and imagine that turning, not as a fast spin, but as a very slow, steady rotation. Like a giant clock hand moving so gently you can't see it shift. Yet you know it's moving because time itself keeps flowing. And now, we'll ease back outward a little, away from the crowded heart, toward the wider disk where most of the Milky Way stars live. In the next cluster of facts, we'll talk about stars themselves, how many there might be, why it's hard to count from inside the galaxy, and the different kinds of stellar neighborhoods that fill our spiral home. Now we'll let the galactic center fade gently behind us, like a bright town far away, and we'll drift back into the broader disk, where the Milky Way stars are spread out like a vast, quiet neighborhood of lights. This cluster is all about stars, how many there are, what kinds, and how astronomers make sense of them, slowly, patiently. Fact 41. The Milky Way contains an enormous number of stars, commonly estimated in the hundreds of billions. You'll sometimes hear ranges like 100 billion, 200 billion, even 400 billion. The exact number is uncertain because we're trying to count from inside a dusty, crowded system. But hundreds of billions is a good, calm sense of scale. Fact 42. Counting stars in the Milky Way is tricky for a simple reason. We can't see every star. Some are too faint, some are too far, and many are hidden behind dust. So astronomers combine observations with models, like estimating how many trees are in a forest by sampling different areas and understanding how the forest is structured. Fact 43. Most stars in the Milky Way are smaller and dimmer than the sun. In fact, red dwarfs, small, cool stars, are thought to be the most common kind. They can burn for a very, very long time, sipping their fuel slowly, like a candle that refuses to hurry. Fact 44. Stars come in a wide range of sizes and temperatures, and those differences affect their color. Hotter stars can look bluish-white. Cooler stars can look orange or red. The sun sits in the middle, warm white with a hint of gold. And you don't have to memorize any of this. Just notice the gentle idea. Temperature becomes color, and color becomes a clue. Fact 45. Stars are not evenly sprinkled through the galaxy. They gather in clusters, associations, and streams. Gravity encourages togetherness. Over time, groups can spread out, but many stars begin life in company, born from the same cloud, under the same dark sky, long before humans ever looked up. Fact 46. There are two main kinds of star clusters you'll often hear about: open clusters and globular clusters. Open clusters are looser, younger groups often found in the disk. Globular clusters are older, tightly packed spheres of stars often found in the halo. Two different moods, one airy and youthful, one ancient and dense, both quietly beautiful. Fact 47. The Milky Way contains many star clusters, thousands that have been cataloged, and likely many more that are faint or hidden behind dust. So if you imagine the galaxy as a city, clusters are like neighborhoods, places where lights are closer together, where history is shared. Fact 48. Astronomers sometimes describe stars in terms of populations, based on age and composition. Older stars often have fewer heavy elements, by which astronomers mean elements heavier than hydrogen and helium. Younger stars tend to contain more of these heavier elements because they formed from gas that had been enriched over time. It's a gentle kind of inheritance. Each generation of stars leaves a little extra variety in the cosmic mix. Fact 49. Our sun is not one of the galaxy's earliest stars. It formed about 4.6 billion years ago, after many generations of stars had already lived and quietly contributed material back to space. Elements that eventually became planets, oceans, and the tiny calcium in your bones. Fact 50. When you look up at night, almost every naked eye star you can see is part of the Milky Way. Those bright points are not scattered randomly through the universe. They're your local neighbors inside the same galactic home. Different ages, different distances, different stories, all orbiting the center together in a slow, steady dance. And that completes facts 41 through 50. If your mind is drifting, that's perfect. You can let the number of stars become more like a feeling, an immense crowd of quiet lights, each one a sun, each one with its own slow rhythm. In the next cluster, we'll move from stars to the space between them, gas and dust, the galaxy's gentle weather, and the calm places where new stars are born. Now we'll drift into the space between the stars. And even though it's called space, it isn't truly empty. It's more like a very thin, very wide sea, so spread out that it feels like nothing. And yet it shapes everything. Fact 51. The material between stars is called the interstellar medium. It's made mostly of gas, especially hydrogen and helium, with a small but important amount of dust mixed in. Fact 52. Interstellar gas can be hot or cold, dense or thin, depending on where it is and what's happening nearby. Some regions are warmed by starlight and energetic processes. Other regions are cold and quiet, perfect for gathering into future stars. Fact 53. Hydrogen is the most common element in the Milky Way's gas. It's like the galaxy's default ingredient, simple, abundant, and endlessly useful for building stars. Fact 54. Interstellar dust is made of tiny solid grains, microscopic bits of carbon-rich material and mineral-like compounds. Even though dust is only a small fraction of the mass, it has a big effect. It blocks visible light, it helps molecules form, and it gives nebulae their beautiful dark lanes and soft edges. You can imagine dust as the galaxy's gentle veil, sometimes hiding, sometimes shaping, sometimes making the light feel more mysterious. Fact 55. Some of the most important places in the Milky Way are molecular clouds, cold, dense regions where atoms pair up into molecules, like molecular hydrogen. These clouds can be enormous, stretching for dozens or even hundreds of light years, and they can hold enough material to form many thousands of stars. Fact 56. Stars are born when parts of these clouds collapse under gravity, not in an instant, but slowly. The cloud cools, gathers, and thickens in places until a dense core forms, like a quiet knot tightening in a soft blanket. Fact 57. As a newborn star begins to shine, its light can make nearby gas glow. These glowing regions are often called H2 regions, clouds of hydrogen that have been energized by ultraviolet light from hot young stars. And the glow isn't the gas burning. It's more like the gas being excited and then relaxing, releasing light as it settles. Fact 58. Many famous nebulae you might hear about, like the Orion Nebula, are examples of stellar nurseries inside our galaxy. They're places where the Milky Way is still actively making new stars, quietly continuing a process that has been going on for billions of years. If you like, imagine these nurseries as warm pockets in a cold night, gentle, luminous rooms where new lights are being prepared. Fact 59. Supernovae, when certain massive stars end their lives, help recycle material back into the interstellar medium. We can describe this calmly. It's part of the galaxy's long-term renewal. Over time, these events spread heavier elements, like oxygen, carbon, and iron, into space, enriching future clouds. It's one of the Milky Way's quiet lessons. Nothing is wasted. The galaxy reuses its stardust again and again. Fact 60. Because of this recycling, the Milky Way is a kind of cosmic ecosystem. Gas becomes stars. Stars shape gas. Stars return material to space. And the cycle continues, slowly, patiently, across immense time. And that's facts 51 through 60. If your eyelids feel heavier now, that's perfect. Imagine the space between stars as a soft, thin mist, barely there, yet deeply important. A gentle medium that carries the story forward. In the next cluster, we'll talk about the Milky Way's mass and gravity, how we know what the galaxy weighs, what holds it together, and the calm mystery of dark matter, explained in a soothing, simple way. Now we'll turn our attention to something you can't hold in your hands, but you can feel in your bones: gravity. Gravity is the Milky Way's quiet architect. It shapes the disk, guides the orbits, and keeps this whole starry home from drifting apart. Fact 61. The Milky Way has a total mass that astronomers estimate to be on the order of about 1 trillion times the mass of the Sun. give or take. You might see values around 1 to 1.5 trillion solar masses in many summaries, depending on the method and assumptions. And it's okay that it's not one perfect number. Measuring a galaxy's mass is like weighing fog in the dark. You do it by watching how things move. Fact 62. Only a small fraction of that total mass is in the form of ordinary matter, the kind made of atoms, stars, gas, dust, planets, and everything familiar. A lot of the Milky Way's mass appears to be something else, something we don't see directly. Fact 63. That something else is called dark matter. Dark matter doesn't seem to emit light the way stars do. It doesn't glow, it doesn't shine, but it still has gravity, so we infer it the same way you might infer wind at night, not by seeing it directly, but by watching what it moves. Fact 64. One of the strongest clues for dark matter comes from rotation curves, measurements of how fast stars and gas orbit the galaxy, at different distances from the center. If most of the mass were only where the bright stars are, you'd expect the orbital speeds to drop off strongly farther out, like planets orbiting the sun, where the outer planets move more slowly. But in galaxies, including the Milky Way, the outer regions can keep moving faster than expected if you only count visible matter. That suggests extra, unseen mass spread out in a broad halo. Fact 65. The Milky Way is surrounded by a dark matter halo, an extended region of mass that reaches far beyond the visible disk. The halo is part of what holds the galaxy together, like an invisible framework, quiet, steady, and spacious. If you like images, you can imagine the visible Milky Way as a glowing pearl inside a much larger, transparent bubble of gravity. Fact 66. Because gravity depends on total mass, astronomers can estimate the Milky Way's mass by observing the motions of objects far out, like satellite galaxies, globular clusters, and distant halo stars, watching how strongly the Milky Way's gravity guides them. The farther out you measure, the more you learn about the halo. Fact 67. Our sun orbits the Milky Way's center at a speed of roughly a couple hundred kilometers per second, often quoted around 220 kilometers per second, with refinements depending on the exact reference frame and measurement. That sounds fast, but in the calm scale of space, it feels like a smooth glide. And as you lie here resting, there's something quietly astonishing. You're part of that motion. You're riding Earth, riding the solar system, riding the galaxy, like layers of gentle currents in a deep, dark sea. Fact 68. Even though everything is moving, the night sky can feel still because the distances are so large and the changes are so gradual. The galaxy's rotation is not something we watch moment to moment. It's something we understand through careful long-term measurement and through physics that has proven reliable again and again. Fact 69. The Milky Way's gravity doesn't just make things orbit in a flat plane. Stars can also bob up and down through the disk over time, like a slow breathing motion, crossing the galactic plane and returning again, guided by the overall gravitational field. It's a soft kind of rhythm, orbiting forward, drifting slightly above, passing through, dipping below, and rising again. Fact 70. When we put it all together, stars, gas, dust, and the invisible halo, the Milky Way becomes a picture of balance, not a frozen statue, but a living system. Motion held in place by gravity, structure held together by mass, and a long, patient stability that has lasted billions of years. Take a slow breath here if you'd like. In gently, and out slowly. And as you exhale, you might imagine the Milky Way as a lullaby made of gravity, an invisible music that keeps everything in its orbit, everything in its place, without strain. Next, we'll drift outward to the Milky Way's companions, its nearby satellite galaxies, its streams of stars, and the gentle signs of the galaxy's long history of meeting and merging with smaller neighbors. Now we'll drift a little farther out to the Milky Way's wider neighborhood, because galaxies, like people, often have companions, not close in the everyday sense, but close in the slow geometry of gravity. Fact 71. The Milky Way has satellite galaxies, smaller galaxies that orbit it, held by its gravity like quiet boats circling a much larger island. Fact 72. Two of the most famous satellite galaxies are the Large Magellanic Cloud and the Small Magellanic Cloud. They're visible from the southern hemisphere as faint cloud-like patches in the sky, like soft smudges of light, gently hovering. Fact 73. The Milky Way has many other, much fainter satellites, often called dwarf galaxies, that can be difficult to spot because they contain fewer bright stars and can blend into the background of the halo. Some were only discovered in recent decades as surveys improved, quietly revealing what had always been there. Fact 74. When the Milky Way's gravity interacts with a smaller galaxy, it can stretch and pull it, creating long, thin trails of stars called stellar streams. A stellar stream is like a ribbon of starlight, evidence of a past encounter spread out across the sky. Fact 75. These streams help astronomers learn about the Milky Way's mass, especially the shape and extent of its dark matter halo, because the stream's paths are guided by gravity like ink lines flowing along invisible currents. Fact 76. One well-known example of an interaction involves the Sagittarius dwarf galaxy, which has been found to be merging with the Milky Way over time, leaving behind streams of stars as it is gradually pulled apart. And we can say this gently: merging isn't a sudden crash. In the scale of galaxies, it's an extremely slow blending, more like two soft clouds passing through each other over billions of years. Fact 77. The Milky Way's halo isn't just empty space with a few lonely stars. It's a place with structure, streams, clusters, and stellar populations that preserve pieces of history, like fossils in a calm, dark museum. Fact 78. Some of the Milky Way's past growth likely came from accretion, the gradual addition of smaller galaxies and gas over time. This is one of the ways large galaxies form and evolve in the universe, not all at once, but bit by bit, through patient gravity. Fact 79. Our galaxy's neighborhood extends beyond its satellites to a broader community called the local group, which includes the Milky Way, Andromeda, and many smaller galaxies. It's like a small town of galaxies, scattered over millions of light years, yet still connected by the faint pull of gravity. Fact 80. Even though the Milky Way has companions, it remains a stable home on human timescales. These interactions unfold so slowly that the night sky looks peaceful and consistent from year to year, while underneath, the galaxy continues its long, quiet story. If you're feeling drowsy, now you might imagine the Milky Way surrounded by gentle neighbors, dim, drifting companions, and long, delicate streams of stars, like threads of memory stitched into the dark. Next, we'll talk about how astronomers map a galaxy from the inside, how we measure distances, track motions, and build the Milky Way's portrait with patient observations, star by star. Now we'll visit one of the gentlest miracles of astronomy, the way humans can map a galaxy while living inside it, not with one big picture, but with millions and billions of small, patient measurements that slowly become a calm, detailed portrait. Fact 81. Astronomers build Milky Way maps using distance measurements. Distance is the key that turns a sky full of dots into a three-dimensional home. Fact 82. One of the most direct distance tools is parallax. Parallax is the tiny apparent shift of a nearby star against faraway background stars as Earth moves around the sun. It's like holding up a finger and blinking one eye, then the other. Your finger seems to move against the background. In space, the shift is much smaller, but with precise instruments, it becomes a reliable ruler. Fact 83. Another important measurement is proper motion, how a star's position changes across the sky over time. Stars aren't fixed points. They drift slowly as they orbit the galaxy. Tracking that drift helps us understand the Milky Way's overall motion and structure. Fact 84. We also measure radial velocity, which tells us whether a star is moving toward us or away from us. Astronomers find this using a star's spectrum, its light spread into a rainbow. If the light is slightly shifted, it reveals motion. It's a quiet, elegant technique, motion written into starlight. Fact 85. A major modern project for mapping the Milky Way is the European Space Agency's Gaia mission, which has measured positions and motions for an enormous number of stars, on the order of billions. That flood of data helps astronomers build a 3D map of our neighborhood and beyond, and it keeps improving as the mission's catalogs are refined. Fact 86. Astronomers don't map only stars. They also map gas. A famous tool here is the 21 centimeter line from neutral hydrogen, radio waves emitted by hydrogen atoms. Because hydrogen is widespread in the Milky Way, mapping this radio signal helps trace the shape of the disk and the spiral pattern, especially where dust blocks visible light. Fact 87. Dust is one of the reasons we rely on multiple wavelengths. Visible light gives us beautiful star fields, but dust can hide whole regions. Infrared can peer through much of that dust, and radio can reveal cold gas. By layering these views, astronomers create maps that are more complete, like combining different senses into one calm understanding. Fact 88. Some stars act like distance markers, objects whose true brightness is known or can be inferred. Certain variable stars, like Cepheid variables and RR Lyrae, brighten and dim in predictable ways. By comparing how bright they appear to how bright they truly are, astronomers estimate their distance. It's like recognizing a familiar lantern. If you know how bright it really is, you can tell how far away it must be. Fact 89. Astronomers also use masers, naturally occurring cosmic laser-like radio sources in star-forming regions, to measure extremely precise distances and motions in parts of the Milky Way. These masers can be bright in radio surveys and are excellent signposts for mapping spiral structure and the rotation of the disk. Fact 90. Because every method has limits, Milky Way maps are built like a quilt, many pieces stitched together. Parallax is wonderful nearby. Standard candles reach farther. Radio maps reveal hidden gas. Spectra add motion and composition. Together, they form a picture that becomes clearer with time, not because the galaxy changes quickly, but because our measurements become more refined. If you're getting sleepy here, you can let the technical parts soften into a single gentle image. Humans, on a small planet, measuring tiny shifts of starlight, turning those shifts into distances, turning distances into a map, until the Milky Way feels less like a mystery and more like a quiet place we can slowly understand. Next, we'll move into the final set of facts about the Milky Way's long story through time and its far future, not in a scary way, more like watching a slow river and knowing it will keep flowing long after we fall asleep. Now we'll let the Milky Way become something even softer than a map, a story told in slow motions, written in starlight, stretched across billions of years. And as always, you don't need to hold on to every detail. Let the facts drift by like gentle constellations. Fact 91. The Milky Way didn't appear all at once. It grew over time, gathering gas and stars through gravity, gradually becoming the galaxy we live in today. Fact 92. Some of the Milky Way's oldest stars likely formed very early in the universe's history. They carry clues in their chemistry, like quiet fingerprints, about what the cosmos was like long ago. Fact 93. The Milky Way has likely grown partly by absorbing smaller galaxies. This isn't a sudden collision like cars on a road. In space, galaxies are mostly empty, and their stars usually pass by one another without direct impact. What changes is their orbits. Gravity slowly reshapes paths, and over immense time, a smaller galaxy can be stretched into streams and blended into the larger one. Fact 94. Those stellar streams and halo structures are like memory traces. They suggest that the Milky Way has a past, encounters, additions, gradual changes, written across the sky in faint ribbons that astronomers can decode. And you can hold that gently. Our galaxy has a history, and it keeps its diary in the motions of stars. Fact 95. The Milky Way is still forming new stars today, especially in regions of the disk where gas remains plentiful. Star formation is not uniform. It can brighten in some areas and quiet down in others. But the overall idea is calm and steady. The galaxy is still alive with creation. Fact 96. The Milky Way also slowly recycles material. Stars return gas and dust to space through stellar winds, and for some stars, their final phases. Over time, that returned material can become part of future generations of stars and planets. If you like, imagine the Milky Way as a very slow-breathing system, inhaling gas into clouds, forming stars, and exhaling enriched material back into the interstellar medium, again and again, without hurry. Fact 97. the Milky Way is part of a small community called the local group, and gravity links that community together. Our nearest large neighbor is the Andromeda Galaxy, and the Milky Way and Andromeda are moving relative to each other through space. Fact 98. For many years, a common prediction has been that the Milky Way and Andromeda will interact strongly in the far future, possibly merging on a timescale of several billion years. The key phrase is several billion. This is not an urgent event. It's a far-off chapter written on a clock so slow that it feels almost like geology, only grander. Fact 99. More recent research suggests the exact outcome may be less certain than people once assumed. The future depends on details like the galaxy's precise motions, the influence of other local group members, and how mass, especially dark matter, is distributed. So you'll hear astronomers speak in careful language, likely scenarios, probabilities, ranges, and that careful uncertainty is a kind of honesty you can relax into. Science doesn't need to pretend. It can simply say, this is what the evidence suggests so far. Fact 100. No matter the exact details of that distant future, the Milky Way will continue to evolve, slowly reshaping, slowly rotating, continuing its long story of gravity and time. And on human timescales, your lifetime, the lifetimes of everyone you've ever known, the Milky Way remains a steady home. The night sky may shift subtly over centuries and millennia, but it doesn't rush, it doesn't lurch, it simply turns. Take a slow breath in here and let it out. And as you exhale, you might imagine the Milky Way as a quiet river made of stars, flowing through time, carrying gas, carrying light, carrying history, while you rest safely on one small shore. Next, we'll do something very simple and practical, a soft, gentle chapter on how to see the Milky Way in the real night sky, without pressure, without technical fuss, just a few calm pointers. Now very gently, let's come back to Earth for a moment, just enough to make the Milky Way feel a little more personal. Because the Milky Way isn't only a concept. On the right night, in the right place, it can be something you simply see. And if you've never seen it clearly, that's okay. Many people haven't. City lights can be bright and life can be busy. Tonight, imagining is more than enough. First gentle tip. The Milky Way shows best under dark skies. Artificial light, streetlights, buildings, stadiums, brightens the sky and washes out faint starlight. Astronomers call this light pollution. A simple rule: the darker the sky, the more the Milky Way looks like a soft, luminous band instead of a barely there hint. Second tip: avoid a bright moon when you want the Milky Way to stand out. Moonlight is beautiful, but it brightens the sky the way a lamp brightens a room. If you want the Milky Way's faint glow, a night near a new moon often helps. Third tip: give your eyes time. If you step outside from a bright room, your night vision needs a little while to settle in. Even 10 to 20 minutes in the dark can make faint stars appear that you couldn't see at first. And if you can, keep phone screens dim. Your eyes are learning the night. Fourth tip: know where to look without stress. In many places, the Milky Way can stretch like a pale river across the sky. The brightest, richest direction is usually toward the galactic center, which, depending on the season and your latitude, may appear lower in the sky or rise at different times of night. You don't have to be perfect about it. Even finding the general band can feel like discovering an old, quiet road in the sky. Fifth tip: use gentle tools if you want them. A simple stargazing app can help you identify the Milky Way's path and the direction of Sagittarius and Scorpius, constellations that point toward the brighter inner regions. But tonight, you don't need an app. You can simply remember the Milky Way is everywhere around you because you are inside it. And one last caring note: if you ever go out to look, keep it cozy and safe. Warm clothes, a calm spot, awareness of your surroundings. The sky is patient. It will wait. Now, we'll return to our quiet ending. A gentle recap, a soft goodbye, and permission to let sleep take over completely. All right, let's begin to close our journey the way we began it. Slowly, kindly, with no pressure to stay awake. If you're still listening, you've traveled a long distance tonight. Not through space in a rocket, but through space in your imagination. And if you drifted off in the middle, and you're only half hearing this, that's perfectly fine too. Let's take a soft breath in and a slow breath out. Tonight, we met the Milky Way as a home, not a puzzle. We began with the simplest idea. A galaxy is a community of stars, gas, dust, and dark matter, held together by gravity, the same steady force that keeps you resting safely on Earth. We pictured the Milky Way as a wide disk with spiral patterns, a brighter bulge in the middle, and a faint halo reaching out into dark, quiet space. We found our address within it, not at the center, but out in the calmer suburbs, about 25 or 26,000 light years from the galactic heart, in a region called the Orion Spur, drifting between larger spiral arms. And we remembered that even as your body lies still, you're part of a gentle motion, Earth turning, the solar system traveling, and the sun orbiting the galaxy in a long, patient loop that takes hundreds of millions of years. We visited the Milky Way's center from afar, the direction of Sagittarius, where dust hides much from visible eyes, and where Sagittarius A rests, massive, quiet, and distant, known through the careful watching of stars that orbit an unseen anchor. We talked about the stars themselves, their countless number, their varied colors and temperatures, their tendency to form in families and clusters, born from shared clouds. And we rested in the space between those stars, the interstellar medium, thin as a whisper, but rich with gas and dust. We imagine molecular clouds as nurseries, and the slow recycling that gives new generations of stars the ingredients for planets, oceans, and life. We held the calm mystery of dark matter too, an invisible scaffolding we infer through gravity, a reminder that the universe still keeps secrets, and that it's okay not to know everything to feel wonder. We drifted out to the Milky Way's companions, satellite galaxies, faint dwarf galaxies, and long stellar streams like ribbons of memory across the halo. And we stepped into the quiet craft of astronomy, parallax, proper motion, the patient measurements that turn tiny shifts of starlight into a three-dimensional map, until our galaxy becomes something we can understand, not completely, but more clearly, with each careful survey. Finally, we looked at the Milky Way as a story in time, a galaxy that grew slowly, changed slowly, and will continue to evolve slowly, so slowly that the far future belongs to timescales of billions of years. In that perspective, your own rest becomes precious, a small, gentle human moment inside a structure so large it could make you feel tiny. And yet, in another way, it makes you feel connected, because you are not outside the universe, looking in. You are the universe, in one of its quiet corners, becoming aware, and then choosing to sleep. Now, let your attention soften again. If thoughts come, you can let them drift like distant satellites, present but not demanding anything. If you notice your breathing, let it be natural. If you don't notice it, that's fine too. Your body knows how to rest. And if you're still awake, you can gently repeat the simplest lullaby of the night. A wide, starry disk, a quiet spiral home, a slow orbit, and you, safe on Earth, allowed to sleep. Good night.